Hello everyone. If you bring a suit or a metal dish and place it on the surface of the water in the bathtub, you will discover that the dish is floating on the surface of the water because it is metal. Now, remove the dish from the water, turn it over, and place it in the water again. And then you will discover that the dish sank into the depths of the bathtub just by changing its position relative to the surface of the water caused the dish to sink. This is only scientific proof of the buoyancy laws of ships. Welcome to the Weird Questions channel, and in this episode, we will answer a question. Why large ships don't sink in water? And before we start, if you still see our channel for the first time, don't forget to subscribe and activate the bell button to receive our videos first. Archimedes, the Greek physicist, has a famous story about the king of the city of Syracuse, in which one of the goldsmiths gave the king a crown of gold that the king requested it from him, but when the king received the crown, he felt something strange about the crown and ordered to bring Archimedes and asked him, "You are a scientist and can do anything?" Archimedes answered him, "Yes." The king said to him, "You will take this crown now and tell me if this crown is real and of pure gold or that the goldsmith mixed it with copper without spoiling or breaking it." Archimedes left the king and he was confused because of the strange request that the king asked of him. And he doesn't know if he will be able to carry out his request or not. The weather this day was hot and Archimedes decided to go to the shower before thinking of a solution to the king's problem. And he went to take a shower. And while he was relaxing in the water, he noticed that when his body descends, the water level rises upwards, and when he descends, there is a force that pushes his body up. From this observation, he deduced the theory that when the body is immersed in the water, a certain weight comes out of the displaced fluid. And this weight is equal to the weight of the body that is in the water, so he decided to bring the crown and put it in the water. And notice the amount of water that will be displaced and weighs this water. And brings a gold bar equal to the weight of the crown and puts it in the water and weighs this water as well. If the two weights are equal, the crown will be pure gold and the goldsmith is wronged. If the two weights are not equal, the goldsmith is deceitful and adds copper to the gold. Archimedes brings a vessel of water and put the crown in it and weighs the water and brings the gold bar and put it in the water, then weighs the water. Here was the surprise. Archimedes discovered the difference in weights and told the king, and the king ordered to arrest of the goldsmith. What do we learn from this story? First, we benefit from it that lying is a bad thing and its consequences are terrible. Secondly, if a body is completely or partially immersed in a fluid, it receives an upward force, which is the weight of the same amount of displaced fluid, which is displaced by the body immersed in it. This is the famous Archimedes rule on which the buoyancy law of ships was adopted later. There is a question spread among the scientific community. It says that the huge ship floats and the nail sinks. And the answer to this topic is so simple. Archimedes said that the submerged body displaces a certain amount of water. The idea is that the condition for anybody to float on the surface of the water is the amount of displaced water is greater than the weight of the body itself. If the condition is met, the body will remain floating on the water without any obstacles. Therefore, we will find three cases related to the law of buoyancy. The first case is that the amount of displaced water is greater than the weight of the body. The second case is that the amount of displaced water is less than the weight of the body, and in this case, the body will sink and will not be able to rest on the surface of the water. And the third case, exactly as you intelligently expected it, which is that the amount of displaced water is exactly equal to the weight of the body, and in this case, the body will not be able to float on water surface. And it doesn't drown at the bottom. If we bring a body weighing 100 kilos and put it in the water, if it displaces 110 kilos of water, it will float on the surface, and if it only displaces 90 kilos of water, it will simply sink, and if it displaces 100 kilos exactly, it will remain stuck in the water. It will not floating or sinking, knowing that a kilo of water is equal to a liter of water. Until now, we haven't said exactly what is the reason that makes the ship float above the water, but all we know is that in order to float, it must displace a large amount greater than its weight. And let us add another piece of information that is the thing which is large in size displaces more water. Now, after these two pieces of information, if we bring a piece of iron weighing 100 kilograms and throw it into the water, it will sink. But what do you think if we change the shape of the iron piece and change its dimensions? And instead of what remains a solid bar, we will turn it into a large iron cube hollowed from the inside. The surprise is that, if you throw this iron cube into the water, it will not sink and float to the surface, even though it is the same piece of iron that we threw in the water and it sank, but the only difference is that we changed its dimensions and enlarged its size. We also made it hollow, which is the magic secret that makes anybody doesn't sink, no matter its size can float on the surface of the water. We change its dimensions to the largest possible size in order to displace the largest possible amount of water. The outer shell of any ship is designed in a certain way to ensure the displacement of the largest possible amount of water, which must be greater than the weight of the ship itself. Air cavity is made inside the ship, and this cavity is capable of keeping it floating on the surface of the water. This is because a large amount of air in the ship's cavity makes its total density much less than the density of water, and therefore it can float safely, and this means that the amount of iron that is used to design any ship and used it in a solid design or cancel the cavity inside the ship. It will sink immediately, like a nail exactly. And the most strange thing is that, if we take a hollow normal ship, but we put it in the water upside down, it will sink. This is similar to the experiment we made at the beginning of the episode. And the scientific reason for the sinking is that we cancelled the air cavity of the body, and there is no uniform surface that the water can push it up. In the end, it means that it is not related to the type of material the ship is made of. Not even that it is a light or heavy material. But the main idea is to change the dimensions of the material we use and make its size as large as possible, and also add an air cavity to it. In the end, we owe all thanks to Archimedes. Because without his theories and the laws he discovered, we wouldn't have been able to understand the mechanism of the buoyancy of ships on the water. And how they can float so easily on the surface of the water. Despite their enormous size, while a small nail can't do that for a few moments. Which is a very strange question in the past. This person has added to us a lot of knowledge that helped us in the modern era. Do you think that he added a lot to humanity or not, and did his laws help you in your life in any way? Write to us your opinion in the comments below this video. This is the answer to a question. Why large ships don't sink in water. If you like it, don't forget to like and share, and people who first see us make subscribe and activate the bell so that you can receive our videos first, and I will see you in the next episode. Goodbye.